Hey everyone, and welcome back to another deep dive. You know we love tackling the big questions.
Absolutely.
And this time around, it's all about learning how to learn. Like, can you actually get better at learning across different subjects, not just one specific thing?
Right, like if you figure out a really good way to study for your biology exam, will those same skills magically help you ace your French test?
Exactly. And that's what we're going to dive into today, thanks to you guys. You sent in this super interesting study.
From the Educational Psychology Review, no
Oh yeah,
less.
this is the real deal.
Published just this year, 2025.
And it's titled, Get Ready.
Exactly. Could that same skill set then help you manage how much effort you put into, I don't know, studying for a history test?
Or even like learning a new language or picking up a musical instrument.
See, I told you it was relatable.
Totally. And this idea of skills from one area, like hopping over to help in another, is what they call far transfer.
Which, this study suggests, might be possible with something called metacognitive regulation.
Okay, that's another one of those mouthful terms. Break it down for us.
So metacognition is basically thinking about your own thinking, like being aware of how you learn best, what strategies work for you when you're getting stuck.
So it's not just about knowing this stuff, but also knowing how you know this stuff.
Right. And regulation is about managing that process. Setting goals, planning, monitoring your progress, making adjustments when you need to. It's like being your own learning coach.
Okay, so metacognitive regulation is basically having a game plan for learning and being flexible enough to change it up if things aren't working.
You got it.
Now, the study mentions that most research has focused on regulating those direct learn techniques, like how you take notes, memorize facts, that kind of stuff. But this study is looking at something different, right?
You're picking up on the key point here. This study dives into how we manage our mental effort, like how much brain power we're actually putting into a task.
Which makes sense, because some things need way more focus than others, right?
Totally. Think about it. Solving a complex math problem versus, scrolling through social media, the mental effort required is completely different.
And I bet that's where this whole far transfer idea comes in. If we can get better at regulating our effort in one area, could that skill transfer over to help us tackle tougher subjects or stay focused when we need to?
That's the million-dollar question they're trying to answer. And to be fair, not everyone's convinced this far transfer is even possible. There are some pretty big names in learning science who are skeptical.
Really? Who are we talking about here?
Well, researchers like Sweller and Passes, for example, they argue that the ability to manage your own learning might be so tied to the specific task at hand that it's basically unteachable as a general skill.
So they're saying it's more about mastering specific techniques for specific subjects rather than having this overall learning superpower that you can apply everywhere.
That's their stance, and there's some research that backs them up. The study mentions a 2020 study that found some evidence for far transfer between different cognitive learning strategies. But then, when they tried to replicate those findings a few years later, it didn't quite pan out.
So the jury's still out on whether this far transfer thing really hold up, but this study is focusing specifically on managing mental effort, right? Let's unpack that a bit more. They talk about required versus invested effort. What's the distinction there?
Okay, imagine you're faced with a challenging task, let's say, writing an essay. Required effort is essentially how much mental heavy lifting the task demands from you. It considers the inherent difficulty, your current skills, all that.
So a really complex essay topic would have a higher required effort. Got it. But what about invested effort?
That's where you come in. Invested effort is the amount of mental energy you consciously choose to put in. It's influenced by your motivation, your goals, even your mood at that moment.
So even if the essay topic is super demanding, I could still choose to phone it in and only invest a tiny bit of effort if I'm not feeling it right.
Unfortunately, yes. And conversely, you could have a relatively straightforward task, but if you're aiming for an A+, you might choose to invest way more effort than technically required.
So there's this interplay between what the task needs and what we're willing to give. And how does this effort monitoring and regulation EMR model fit into all of this?
The EMR model, developed by De Bruin and his team, is basically a framework for understanding how we manage this mental effort dance. It says we're constantly picking up on cues during a task.
Cues like what?
Things like how challenging the material feels, whether we're making progress, if our mind is starting to wander. And based on those cues, we decide how much effort to invest.
So if I'm reading a textbook and suddenly realize I haven't absorbed a single word in the last 5 minutes, that's a cue that I need to dial up my effort, right?
Exactly. Or if you're working on a problem and it feels way harder than you expected, that can be a cue to adjust your strategy or even reevaluate your goals.
Makes sense. So this EMR model is all about that feedback loop between noticing how things are going and adjusting our effort accordingly. Now, let's get to the heart of this study. How did they actually test whether learning to regulate effort in one area could transfer to another?
All right, so they did a field study with a large group of 5th and 6th graders. Pretty brave, if you ask me.
Yeah, real-world research can get messy. What was their setup?
They divided the students into 3 groups, 2 training groups and a control group. And the key here is that both training groups focused on learning how to manage a cognitive learning strategy.
Like a specific technique for learning something.
Yep. In this case, it was the process of conducting science experiments.
So like the classic, form a hypothesis, test your variables, draw conclusions kind of thing.
That's it. They had 15 weekly sessions, 90 minutes each, learning about the steps involved, how to plan their experiments, monitor their progress, and reflect on what they'd learned. They even had this cool learning buddy tool to help them keep track of everything.
Sounds pretty thorough. What about the other training group? Did they get something different?
They got the same science experiment training plus what they called indirect training. This happened during their regular German language classes. Their teachers were encouraged to use similar language and prompts about self-regulation.
So instead of just focusing on the science experiment, they were getting these subtle reminders about managing their learning in another subject altogether. Sneaky. But how did they measure if any of this training actually made a difference in their ability to regulate mental effort?
Okay, here's where it gets interesting. They used a test called the multi-strategy test, or MST for short. They had 2 versions of this test, which they gave the students before and after the 15 weeks of training.
2 versions, why?
One version was called MST experimentation. This directly tested their ability to use the trained cognitive strategy designing a paper airplane experiment.
So they were probably feeling pretty confident in that area since they'd just spent weeks learning about it.
Exactly. But the other version, called MST exam preparation, was a more general task, more like what they'd encounter in everyday school life. They had to think about how they'd prepare for an exam in any subject.
Interesting. So one task was in their comfort zone, the other was more of a wild card. Did they just observe how the kids approached these tasks?
Not quite. After each task, the students had to rate 2 things on a 9-point scale. First, how much required mental effort they thought the task needed to get a good grade, and second, how much invested mental effort they actually put in.
Ah, so they were measuring that gap between perceived effort
Mhm.
and actual effort. Clever. What did they find? Did the training actually help them bridge that gap?
Okay, drum roll, please. The results were pretty fascinating. Both training groups showed significant improvement in their ability to regulate mental effort compared to the control group.
So, learning to manage your approach in one area did have the positive impact on how they managed their effort overall. Case closed, FAR transfer is real.
Well, hold on. The effect size was small.
Okay, so statistically significant, but maybe not a life-altering difference. Did the type of training matter? Like, did those extra prompts in German class make a bigger impact?
Actually, no. There was no significant difference between the 2 training groups. In fact, the group that only had the direct science training showed a slightly larger improvement.
Huh, that's unexpected. You'd think more reinforcement would equal more improvement. What about the 2 different tasks? Did the training have a bigger effect on their effort regulation in the science experiment versus the general exam preparation?
Nope, the improvement was similar across both tasks, which suggests that those regulation skills did transfer, at least to some degree.
Interesting. Any other key findings?
One more. They found a weak but significant correlation between the students' effort regulation scores and their performance on both tasks.
Meaning, the better they were at managing their effort, the better they tended to do. Makes sense.
Yeah.
But of course, no study is perfect. What were some of the limitations they highlighted?
Well, they acknowledged that measuring required effort based on the student's self-assessment is tricky. Kids aren't always the best judges of how much effort something actually needs.
True. What else?
They also pointed out that the pandemic might have thrown a wrench into things, especially with the indirect training in the German classes. It's possible that the implementation wasn't consistent across all the teachers and classrooms.
Yeah, that's the reality of real-world research.
Uh-huh.
Unforeseen circumstances can always pop up. But even with those limitations, they still see this study as an important step forward, right?
Absolutely. It provides more evidence that these self-regulation skills might be more generalizable than we thought, and they open up a whole bunch of new research questions.
Like what?
Well, for example, how can we better understand the cues students use to decide how much effort to invest? And can we teach them to recognize those cues more effectively?
And how can we move beyond just looking at the amount of effort and start focusing on the quality of effort? Like,
Mhm.
are they strategically directing their attention to the most important parts of the task?
All great questions for future research.
So to wrap this up for our listeners, what's the key takeaway from all of this? What should they be thinking about as they go about their own learning?
The main message is this. Learning how to manage your learning process in one area can actually have a ripple effect on how you approach learning in other areas, even if they seem completely different on the surface.
So if you figure out a really good way to study for your biology exam, it's possible that those same skills could help you tackle that challenging coding project or even learn a new language.
Exactly. It's about developing those metacognitive muscles, those skills for planning, monitoring, and adjusting your approach. And those skills might be more transferable than we give them credit for.
Which leads us to a final thought for you to ponder. Think about your own learning experiences. Have you ever noticed a skill you picked up in one area surprisingly helping you in another? Maybe you got really good at breaking down complex problems in math class and then realized you were using that same approach to troubleshoot issues at work.
Or maybe you learned to manage your time effectively while training for a marathon and found that those same time management skills helped you stay on top of your deadlines at school or work.
Exactly. These far transfer moments are all around us. The question is, how can we become more intentional about cultivating them and making them a regular part of our learning journey? That's something to think about as you go forth and conquer your own learning goals. Thanks for joining us on this deep dive, everyone.